Hi, this is Dr. Barney. I realize that after the storm, many of you may not be coming to class today. So in preparation for that, I'm actually going to record this session as a WIMBA session. So you get to see everything that we've done in class, and that way any of you who are going to be working on homework outside of class today will still be able to benefit from some of the lecture and the notes that we've gone over during today's session. I hope everyone's doing all right following the storm. I've heard a number of reports from different people about some loss of property and still a loss of electricity, so I hope everybody's doing well. And I know certainly it is understandable that some of you may not be here today. If anybody has any questions, feel free to email me at any point with any of those or even just concerns if you'd like to get in touch with me. I'm always available, so send me an email and let me know. Now, the college, or more specific to the MSW program, typically doesn't offer hybrid or online courses. However, I'm making a special exception in this instance where I'm going to be providing this lecture in the form of an online classroom just because of the storm and some of the problems that students are facing in relation to getting to the college and getting here for the lectures. So this will not be offered at all during this class. In future, it's just a once-off online lecture for you due to the storm. All right, during today's class, we're going to be talking about hypothesis testing, and I'm going to be giving you an introduction to statistical tests. Just to give you a little bit of an overview of our session, we are going to start with a bit of a review. We're going to go over levels of measurement. We're going to talk about measures of central tendency and charts and graphs. This has all been covered previously in some of our previous homework assignments. If anyone has any questions about this, maybe you might forget how exactly to run measures of central tendency or charts and graphs, please make sure to refer back to your previous homework assignments and some of the PowerPoints that have been given to you previously. Next, we're going to be talking about hypothesis testing and the different types of hypotheses that are available to you. This is really important because this forms the foundation for statistical tests. You have to establish a hypothesis and relationships between variables so that we know what types of statistical tests to run. And then we're going to talk today about selections of statistical tests. We're going to talk about some of the different statistical tests that are available to the researcher. Again, this is all based upon levels of measurement. So I am going to be showing you today exactly how to go about selecting which statistical tests are the correct ones, but we will not be running any of these statistical tests today. So again, it's just an introduction. We won't be running these statistical tests during today's session. Now, probably something that's going to help you quite a bit during today's session is actually going to be the statistics cheat sheet, which was provided to you earlier in the semester. Just to give you an idea of exactly what this looks like, I am going to just show you very quickly what this looks like. Okay, and in front of you now, you should see a copy of the statistics cheat sheet that we have been using this semester. Under this first level, you are going to see determining levels of measurement and how we go about determining what level of measurement each variable actually is. In the next category, there's determining measures of central tendency. And again, based upon the level of measurement for each of the variables that you're using, you can select the appropriate measure of central tendency. The same is true for graphs. This was all covered during last week's, or 2 weeks ago, our homework that we had completed. And then this final portion on the cheat sheet is what we're going to be talking about today, determining appropriate types of statistical tests. And this gives you an idea of how you go about selecting the right statistical test. And we're going to be covering this in a little bit more detail. So again, this is a great cheat sheet to use as you're going through some of these assignments. It refers you specifically to how we go about choosing the right measures of central tendency, the right graphs, and the right statistical tests, all based upon levels of measurement. And again, again, that's why it's so important that we spend time going over this content and reviewing that now. Okay, just to continue along, I'd like to provide you with a little bit of review of some of the levels of measurement. And again, this is just a little bit of practice for you to get you kind of reminded and back in the game, as it were, in preparation for understanding hypotheses and the correct statistical tests. So in order to do this, I provided you with a couple of examples. And the first example is, what was your ranking in the 6th grade 100-meter dash? And you see the response categories that are available are first place, second place, and third place. What I'd like for you to do is first identify the level of measurement for this question, then identify the appropriate measure of central tendency, and then identify the appropriate graph for this particular variable. So if you need to take a minute to think this through, refer to your cheat sheet. Go ahead and pause this video just to give yourself a chance to think through this, and then I'll give you the answer in just a second. Okay, so the level of measurement for this variable, we have first place, second place, and third place. These are numerical values, but there's no absolute zero. So I would say that this is interval level of measurement. The correct measure of central tendency for something like this, if you refer back to your cheat sheet, we know that for interval levels of measurement, the mean would be appropriate. And then the appropriate graph for a variable such as this is going to be the histogram. So again, just refer back to your cheat sheet and you'll see exactly what the correct measure of central tendency as well as the correct graph would be for each of these different variables. All right, let's go on to our next example. What is your ethnicity? And let's say that the response categories for something like this might include Black African American, Caucasian, Asian American, Latino Hispanic, and so on. So these are our response categories. So again, identify the level of measurement, the appropriate measure of central tendency, and the appropriate graph. And go ahead and pause the video just to give yourself a chance to think through this on your own. Okay, the correct level of measurement is nominal. We have categories, but these categories are not ranked in any way. So there's no rank order, so it's just a nominal level of measurement. The appropriate measure of central tendency for a variable such as this is going to be the mode, and the appropriate graph is going to be a bar or a pie chart. Let's go on to our next example. Okay, here we're looking at a single item on the Beck Anxiety Inventory, and you see that item is listed here. I feel tense or wound up. And the response categories are on a Likert scale. So there's a ranking to these. Response categories include most of the time, a lot of the time, from time to time, or not at all. So pause your video just for a second now and think through what's the level of measurement for this variable, what's the corresponding measure of central tendency, and what would be the appropriate graph for this variable. Okay. As we've talked about in the past, single items included on Likert scales are going to be considered by most people to be ordinal levels of measurement. So we see a rank order. These are different categories, but there's rank orders to them. Most of the time it's more severe than a lot of the time, and a lot of the time more than from time to time. So there's a ranking, but we can't say that there's equal numbers between each of these different groups, or there's equal spacing between each of those groups. So it's just ordinal, and that's what it is. And you'll want to remember that for pretty much any scale that you're dealing with. Single items on those scales are going to be ordinal levels of measurement. So make sure to make note of that. I'd even write that on your cheat sheet just so that you do remember it for the future. So then identify the appropriate measure of central tendency. Refer back to your cheat sheet, and you'll see that for ordinal level of measurement, the median is going to be the measure of central tendency that you will want to report. The appropriate graph for a variable such as this, if we wanted to give a graphical representation of the different responses, would be either a bar chart, a bar graph, or a pie chart. So either one of those two would be appropriate. Again, this is true anytime that you're using a single item on a Likert scale. look at our next example. Here, what we're talking about is the summated score from the Beck Anxiety Inventory. And you remember last week, or 2 weeks ago, excuse me, we had talked about summated scales. And a summated scale is when you take each of the individual items included on a scale, such as the Beck Anxiety Inventory, and you add them all together. And we had gone through how you actually go about summating a scale such as this. We practiced doing that together as a class. And what comes up as a result is you have multiple response categories, such as what you see here for the scoring for the Beck Anxiety Inventory. Minimal anxiety would be between 0 and 7 points. Mild levels of anxiety would be between 8 and 15 points. Moderate anxiety would be between 16 and 25, and severe would be between 26 and 63. Now, these points on the total scale really just correspond to the number of items that are actually included in the scale, as well as the maximum and minimum number of response categories. So it would be between 0 and 63. But this gives us a new score. And the question becomes, what is the level of measurement for this summated scale score for each of our respondents? So take a minute to pause the video and think through what's the level of measurement for a summated scale score such as this. And then what's the corresponding measure of central tendency, and what's the corresponding or the appropriate graph for a variable such as this. All right, let's talk it through now. Scoring of the Beck Anxiety Inventory. What you see here is that we have numbers associated with each of these different categories, and the numbers give us a new score. These scores range between 0 and 63 points. Most people would consider this to be either interval or ratio level of measurement. There's arguments for and against both categories, but what you see is that when you add the items together for each of these scales, we go to a higher level of measurement. So it's interval or ratio. And this is going to be true anytime you're working with a summated scale, such as a Likert scale. So interval or ratio is true for summated scales. Then what is the appropriate measure of central tendency for interval or ratio levels of measurement? Measure of central tendency that's appropriate is the mean. And then the appropriate graph would be a histogram. So again, anytime you add these items together, you increase the level of measurement and you change the measures of central tendency that should be used for each of these types of variables. All right, our final example, how do you feel about statistics? And here you would be asked to identify the level of measurement for the question, identify the measure of central tendency, and identify the appropriate graph that you might use to represent this data. Okay, so what's the appropriate level of measurement? It's going to be ordinal. We see numbers associated with each of these categories, but what we're really talking about is the response categories themselves. And we see different faces ranging from a happy face all the way to a very distressed or very sad face. So I would say ordinal for something like this. Measure of central tendency is going to be the median, and the appropriate graph is going to be a pie chart or a bar graph. All right, let's move on in our session. And next, we're going to be talking about hypothesis testing, looking at relationships between variables. In the past, we've been talking about single variables and how our different respondents represent themselves in relation to these single variables. So how anxious are they relating to a single item on the Beck Anxiety Inventory? Or we can look at the single variable, which is the summated scale total. What was their total score? And we talk about measures of central tendency, what the average score was for the Beck Anxiety Inventory among our respondents. And we could also talk about single items on those scales. We've looked at how to analyze each of those variables independently. But now we're looking at relationships between variables. So let's talk about some of the different types of hypotheses that are available to the researcher to examine these types of relationships. A hypothesis specifies a proposed relationship between two variables. increases, or the responses from one variable increases, what's going to happen to the other? A hypothesis proposes a relationship or a guess at what's going to happen to these two variables, how they're going to be related. Now, there are two different types of hypotheses. There's a one-tailed research hypothesis, which specifies a relationship between variables, and it predicts values for how one variable predicts direction of values for another variable. Okay, so for instance, we work with the following scenario. Female social workers have higher levels of empathy than male social workers. So first off, we want to determine what are the two variables that we're actually talking about in this hypothesis. The first would be gender, because we're talking about male versus female. And then the second variable is actually going to be empathy. Okay, so take a moment to just think through which one would be the independent variable and what would be the dependent variable. Remember, the independent variable comes first. It does the influencing, whereas the dependent variable is the thing that comes after, or the thing that is being influenced by the independent variable. Take a moment just to think through this and pause the video if needed. All right. Consider that gender is something that's always there. It's always going to come first. So gender is the variable that is the independent variable, and the dependent is empathy. Okay? So we're looking at the relationship between gender and levels of empathy. Now, the one-tailed research hypothesis specifies the relationship or the direction. So we see that female social workers are going to have higher levels of empathy. But we have what's also known as a two-tailed research hypothesis, which specifies that there's a relationship between the variables, but it doesn't actually predict the direction of the relationship. This is also known as a non-directional hypothesis. An example of something like this that corresponds to our previous example might be gender is related to empathy, or gender is related to levels of empathy. We're working with the same variables, but we are not specifying the direction of the hypothesis itself. So either one of these would be acceptable for researchers and are often used by different researchers. All right. Most researchers are going to be working with one-tailed research hypotheses. They are going to be specifying the relationship and the direction of relationships between two variables. Now, there are further types of one-tailed research hypotheses. The first type is what's known as a positive correlation. This is when higher values of one variable are found with higher values of another variable. Or correspondingly, we may have lower values of a variable being found with lower values of a second variable. So let's give an example. Say we're working with a person's levels of anxiety in comparison to another variable, levels of depression. Most researchers would hypothesize that as levels of anxiety go up, we're also going to see higher levels of depression. So they go in the same direction. As depression increases, anxiety also increases. The same would also be true when we're talking about lower values. So when we see lower values or lower levels of anxiety, we're also going to experience lower levels of depression. Okay. Now, the second type of correlation that's often going to be present with one-tailed research hypotheses would be negative correlations. Okay, and this is when high values of one variable are found with low values of another variable, or vice versa. So let's talk about another example that may fit in this type of scenario. Let's say we throw in a variable such as levels of self-esteem in comparison to a person's level of anxiety. We could probably hypothesize that as a person's level of self-esteem goes up, their levels of anxiety go down. The same might be true if we're talking about self-esteem and depression. If a person has high self-esteem, they're probably going to have lower levels of depression. Now, that's not always going to be true among every population. You would want to test a hypothesis such as this, but it would seem to be an appropriate hypothesis to test, and one that represents a negative correlation, where high values of one variable relate to low values of another variable. All right. Let's talk about another correlation example. Among adolescent psychiatric patients, those who have higher group treatment session attendance will be more likely to have higher self-esteem scores. All right. So take a moment just to think about what this means. Are we talking about a positive or a negative correlation? As you see from the next example, what we're working with is a positive correlation. And this is because as as the number of group treatment sessions increases, we also see higher levels of self-esteem. A positive correlation could also be found if we're talking about low numbers of attendance with low levels of self-esteem, because they're both going in the same direction. Just because we have low levels doesn't mean it's negative. Negative refers to opposite scores. Okay, so we're talking about a positive correlation. Now also take a minute just to think about what is the independent variable and what is the dependent variable. Pause the tape and consider why. Okay, the two variables that we're working with here, group treatment session attendance and self-esteem scores. So those are our variables. Which one comes first? Well, in this statement, what's stated or a case that's made is that attendance will be measured first and self-esteem later. So what's being inferred here is that attendance is the independent variable and self-esteem scores are the dependent variable. You could probably also make a case for the exact opposite to be true, but you would probably have to measure self-esteem before you measure attendance in order to establish self-esteem as the independent variable. So really it does depend on at what point in time you do measure these particular variables, because remember the independent variable should come before or should be the variable that is influencing the dependent variable. Okay. Now, in addition to one-tailed and two-tailed research hypotheses, another term that you're going to hear thrown around is the term known as the Null research hypothesis. This is a hypothesis that says there's no relationship between two variables. In other words, the relationship that's observed between two variables is really just due to chance. It's due to sampling error. There is no relationship between the variables. So there is an example of this. There's no relationship between self-esteem and depression. There's no relationship between anxiety and depression. Hypothesis testing is really concerned with refuting the null hypothesis. We want to show that there is a relationship between variables. Part of the reason why it's so important to understand this is because many statistical tests are often based upon refuting the null hypothesis. So you may hear this thrown around quite a bit, but it's just a different type of hypothesis that's available to the researcher, and this is what we compare all of our one-directional and two-directional hypotheses to. Okay, let's take a minute to think through a specific activity. And this will provide us with a good example to work from. A few years ago, I had students who participated in creating evidence-based practice projects. So they identified new techniques, new interventions to use among some of their different clients. They conducted literature reviews in order to assess what would be the best interventions. And one of my students actually developed an animal-assisted therapy program for residents of a retirement community. They found that this would help be a way to lower depression among elderly clients and increase levels of socialization. Now, a presentation was actually given to the residents of the retirement community prior to any sort of intervention with them. So before the animals were actually there, they gave a presentation just to give some of the practitioners as well as the clients there at the retirement community an idea of where the student would be going. Following the presentation, a survey was actually distributed by the MSW student who had actually conducted the presentation. And the presentation survey was completed by some of the staff members who were in attendance on that day. So what I'm going to do now is show you a copy of the presentation survey that was actually included. And what we're going to be doing next is reviewing some of the different types of questions and the variables that were included on the survey. So let's refer now over to the survey. A copy of this is provided on Blackboard, so you could log into Blackboard and download a copy of the survey itself to review on your own, and you can follow along as well on the video as I share this with you. Okay, so here is a copy of the survey that was distributed by the student, again, after giving the clients as well as the staff members information about animal-assisted therapy. All right, so the first section assessed the respondents' levels of satisfaction with the presentation itself. Some of the individual questions that were asked, the timing of the presentation was convenient, and respondents could answer on a Likert scale ranging from 1 through 7, representing not at all, somewhat, and very much so. Some of the other questions that were included the meeting space, was conducive to learning. The way this presentation was delivered was an effective way for me to learn about subject matter and so on. So this really has to do with satisfaction with the program and the presentation itself. Now this can be summated into a total scale score. So with the Likert scale, we can add all of the items together, generate a new variable, a summated scale score, to give us an overall satisfaction score for the presentation. But this is something that you have to do in SPSS on your own if you want to use it. All right, the next variable that's available here is in the space below. Please share any other comments that you have about the presentation. This represents a string variable. Just type this information in because it's words. It's not any sort of numerical variable that we can use. Now in the next section, what you see are questions for practitioners about their own practice and how they use some of the information in their own practice. And the first question is, I am already aware of the best practice information that was presented. So the information about animal-assisted therapy, were they aware of it or not? Did they strongly disagree, agree, or strongly agree with this statement? The next question, I would like to apply the information that was presented. I'm interested in learning more about the information. So this really refers to their own practice and how much they use or want to use some of the information about animal-assisted therapy. Our next section, my coworkers. So the respondents are asked to indicate information about their coworkers relating to animal-assisted therapy. Are they aware of the information? Would they be open to applying the information? Are they interested in learning more about the information? And do they know how to best utilize the information itself? Respondents are also asked to indicate information about their agency. Is the agency aware of the information? Are they applying it? Are they interested in learning more? And do they know how to best utilize the information itself? Each one of these sets of questions can also be summated into a total scale score. So in my own practice, this would be my practice total scale score. My coworkers, this is coworkers practice total scale score. And you can add the last 4 items together to form an agency practice total score as well. Moving down to our next category, we see a number of questions about the organization in general. There's a diverse array of different questions that are asked here. Again, these can be summated. You see questions about team leaders making an effort to motivate team members, team leaders supporting the ideas of their team, learning being important at the organization, individuals being free to make decisions, and so on. So a number of questions in general about the organization. One of the things that you want to pay attention to are the reverse scored items. Remember, for that any one of these scales, there are going to be items that are in the opposite direction. And I've actually highlighted for you what those items are. So we see the ones with an asterisk beside them representing reverse scored items. So you need to make sure that you're reverse scoring them before you summate them and use them for your analysis. All right. Our next category of questions following statements are designed to assess your attitudes towards learning. So we've asked questions about the presentation itself. We've asked questions about an agency as well as individuals' willingness to use some of these strategies about animal-assisted therapy at the agency. We asked questions about the organization, and now we also want to understand the respondents' attitudes towards learning, because it could be that people didn't want to learn about animal-assisted therapy, but it has nothing to do with animal-assisted therapy itself. It has something to do with them just not wanting to learn information or having poor attitudes towards learning in general. So these questions help assess for something like this. Things I learn are useful. It's easy for me to use what I know in new situations. It does not matter if I do well or poorly. I improve after finding out. So really what we're doing is we're assessing attitudes towards learning, which could also be used to develop some interesting research questions or hypotheses. And then finally, we ask a number of demographic questions. What is your current position at the agency? How many years to the nearest half have you been employed in your current position at your agency? How many years to the nearest half of professional experience do you have? What is your gender? What is your age? What is your self-identified race or ethnicity? And what is your highest level and type of education that you have completed? So we have all of this information available to us, all the variables that are included on this survey. But the next question would become, what would be a good research hypothesis to ask using this type of information? What would be a good hypothesis to develop? Well, I've already actually suggested one a little bit earlier, and that has to do with the relationship between learning and the relationship between that and satisfaction with the presentation that was delivered to some of the home health aides or the practitioners at the agency itself. My hypothesis would be that individuals who have high appreciation for learning will have higher levels of satisfaction with the presentation itself. And that's a directional hypothesis, and it represents a positive correlation, which we've been talking about a little bit earlier. I want you to take a moment, pause the video, and I want you to consider what is a good hypothesis to ask using some of our other variables. And you could identify an individual item and talk about how it might be correlated with another item, or you could be talking about summated scale total scores, which is often a little easier to work with. You could also integrate and use some of the demographic questions included on this survey as well. So take a moment, think it through, try and identify a hypothesis, and it's probably better to go with a one-tailed hypothesis, which specifies a direction or a relationship between some of these different variables. So take a moment to think that through. Okay. Let me give you one other example of a variable that represents a one-tailed hypothesis. Let's say that I want to develop one that relates or that is a negative correlation, so where the variables are going in opposite directions. Let's say that I want to use age and a person's ability to use or willingness to use the information in their own practice. To develop a negative correlation hypothesis, I would say that the younger a person is, the more likely they are to use the information in their own practice. Now, I'm not sure I could really make a case for a hypothesis like this. In fact, the opposite may be true, that as a person gets older, they may be more willing to use the information in their own practice. But that would be an example of a negative correlation hypothesis when the lower a person's age is, or the younger a person is, the higher or more likely it is that they will use this information in their own practice. So again, consider what would be a hypothesis that you could ask using some of the additional information. All right, let's go back to our PowerPoint. And let's continue talking about statistical tests. Now, so far we've talked about, we've done some review, levels of measurement, measures of central tendency, and graphs. We've talked about the types of hypotheses that are available, and really when we're talking about hypotheses, we're talking about the relationships between variables. And now we're going to be talking about some of the different statistical tests that are available to the researcher. Now, statistical tests help us to actually analyze the information and make the information useful. So we generate results about the variables, and then we try and identify what are the actual results, what are the actual relationships that exist between variables. Were our hypotheses correct, or were they incorrect? Now, there are two major types of tests that we are going to be talking about this semester, or for the rest of the semester. The first type include parametric tests. These types of tests are going to be used when the dependent variable is interval or ratio levels of measurement. This is also the type of test that we use when we have large samples. So these are more powerful tests, and they're better at detecting significant results. But there are also tests known as non-parametric tests, and use these tests when the dependent variable is nominal or ordinal. So again, they work with lower levels of measurement, and you can also use these when you have very small sample sizes available to you. So these are kind of the measures of last resort. Remember how I mentioned that you can take ratio and interval level data and actually change this to nominal or ordinal levels of measurement. So if you had a score on a scale, a summated scale, where your possible response categories, such as on the Beck Anxiety Inventory, include 0 through 63. You can break these these scores up into different response categories. So it could be low levels, medium levels, or high levels of depression, and create a new variable which would be ordinal, low, medium, and high. So now we wouldn't be working with the numbers themselves, but really what those numbers might represent. So you can break them down, and if you don't want to use the parametric test, you could then use a non-parametric test. But the same is not true in the reverse. You can't take a variable that has been recorded in the form of ordinal level data and change it to interval or ratio. So you can go down in terms of levels of measurement, but you can't go up. So it's often best to structure your questions in ways where you're using interval or ratio level data, and then you can change it later to nominal or ordinal if needed. And this is what we often see with these statistical tests, where a researcher will start with a parametric test, but if that's not possible, if maybe we don't meet all of these different assumptions, say we don't have enough people participating in the survey, we have a low sample size, we can then change our research variables to nominal and ordinal levels of measurement and then use a non-parametric test. So it's really important that you understand the difference between these two, parametric as opposed to non-parametric, because we're going to see this pop up as we continue along this semester. All right, so these are the two types of statistical tests. And this chart, which has been included on your cheat sheet, which I showed you a little bit earlier, gives us a great overview of the different types of tests that are available and the different levels of measurement that are associated with each of the different variables. So let's start with our parametric tests. And one example of a parametric test actually includes a Pearson R. And a Pearson R is the test that's used when the dependent variable is interval or ratio, and the independent variable is also interval or ratio. Okay. A parametric test can also be an independent t-test. So this is another example. And you use this particular type of parametric test when your dependent variable is interval or ratio. But the independent variable is a little bit different. The independent variable would actually be nominal. And nominal when you have two groups. included in that nominal category. So let me give you an example of this because it's getting a little bit complicated now. All right, let's say that we are looking at levels of self-esteem among men and women. So gender would be the independent variable, and self-esteem would be the dependent variable. So we're just looking, is there a difference between men and women in terms of their levels of self-esteem? The independent variable is gender. This is a nominal variable, and it has two groups, men as opposed to women. So for a research question that includes these two variables, or a research hypothesis that includes these two variables, we would use interval or ratio for the dependent variable, and the independent variable is nominal with two groups. So the independent t-test is appropriate here. Now, the one-way ANOVA is very similar to the independent t-test, but instead of having two groups, we have three or more groups. So for something like this, we could include a different variable for our independent variable. Let's work with race. Race doesn't just have to have men and women. Instead, it could include Caucasian, African American, Asian American, and so on. So we're looking to see, is there a difference in the levels of self-esteem between these three or more groups? And for this type of research hypothesis, we would use a one-way ANOVA. So again, really once you identify the variables included in your hypothesis, you would be able to determine what statistical test is appropriate for that hypothesis. Again, it's all linked to the levels of measurement that we're using for these variables. Now, there's also what's known as non-parametric tests. And non-parametric, as we said, work with nominal or ordinal levels of measurement. And typically what you find is that for every parametric test, there's a non-parametric alternative. So if you are working with ordinal levels of measurement, where your dependent variable as well as your independent variable are both ordinal, instead of using the Pearson R, which uses interval or ratio, we use the Spearman-Rowe for ordinal levels of measurement. So there's an alternative for each one of these. And basically the reason why we say there's an alternative is because even if we're not able to use the Pearson R, we can break some of this data down and use it at the ordinal level of measurement. Okay. Now there's also a final test at the very bottom of this spreadsheet known as the Chisquare. And the Chisquare, there is no parametric alternative. But basically what we're using this one for is when we compare nominal levels of measurement with other nominal levels of measurement variables. Okay. Let's talk about these statistical tests in just a little bit more detail. I've given you an introduction to how we go about actually selecting these tests, but I want to give you a little more background information about what these tests actually are. Okay. The first category of tests are what's known as tests of association. Here we're just looking at relationships between variables. This includes Pearson R as well as Chisquare. There's a second category known as group differences. These include the independent t-test as well as the one-way ANOVA. So let's talk about what this means in just a little bit more detail. First test of association is the Pearson R, as I've mentioned, and as we recall from the chart that we've just looked at a few minutes ago. The independent variable is ratio or interval, while the dependent variable is also ratio or interval. This is a parametric test, but it has a non-parametric alternative, which is the Spearman-Rowe. Again, if you break some of this data down from the ratio and interval levels of measurement over to ordinal, we use the Spearman-Rowe. So you can kind of dumb it down in a sense and make the data more simple, change it over to ordinal levels of measurement. This is a test of association. And basically, a test of association examines to see if there's an increase in the independent variable. Will that result in an increase in the dependent variable? Or does a decrease in the IV result in a decrease in the DV? Or Or our third alternative, which would be a negative correlation, does an increase in the IV result in a decrease in the DV? Okay, what I want you to do is look back at the post-presentation survey data. Try and identify two variables that can be used for this type of statistical test. And I want you to phrase an appropriate research hypothesis. I know the PowerPoint says research question, but develop a hypothesis. Take a moment to think that through. Again, your independent variable needs to be ratio or interval for this type of test, and the dependent variable also needs to be ratio or interval. Take a moment to think that through. Look over the handout with the questions included on the survey and see if you can identify two variables that are ratio or interval that we could use a Pearson R to investigate. What is that hypothesis? Okay, you should have paused the tape by now and come up with a research hypothesis that would use the Pearson R statistical test to analyze. So let me give you my example, which is people who have more positive attitudes towards learning will have higher levels of satisfaction with the presentation. So this is the one that I gave a little bit earlier. It represented a positive correlation research hypothesis. But to analyze this, we would also use the Pearson R. So that would be the appropriate research test or statistical test to test our hypothesis. All right, let's move on to another test of association, which is a chi-square. If you refer back to your cheat sheet in the chart, a chi-square is used when the independent variable is nominal and the dependent variable is also nominal. Now, this is a non-parametric test, so there is no parametric alternative. This is a test of association. Does an increase in the IV result in a decrease in the DV? Or when we find one category of the IV, are we going to find another corresponding category in the DV? Let me give you an example of something like this. We might use the chi-square when we're talking about gender and types of education. Types of education I would not rank, and this is because a person can have a professional degree or professional certification, but who's to say whether or not this is higher or lower than a college degree? Really, can we really appropriately rank some of these different categories that are available to us? Many people would see education as being ranked in some way or another, but it gets a little bit confusing once you get into those higher levels of education. What is higher ranked than others? And therefore, you really often can't put that particular variable in the form of ordinal level data. So you just have to talk about these as being categories. Let me actually just take a second to go back to our handout just so I can show you this a little bit more clearly. I think it needs a little more explanation. All right, it'll just take me 1 second. All right, here we are back to our survey that we've been using for this particular data set. And what we see here, we scroll down to the very bottom. What is the highest level of education that you have completed? We see high school diploma, professional certification, associate's degree, bachelor's degree in another field, master's degree in another field, and a doctoral degree. Okay, so is professional certification higher or lower than an associate's degree? We really don't know. Is a bachelor's degree in social work higher or lower ranked than a bachelor's degree in another field? Again, we don't know. So I wouldn't say that these are ranked ordered. These are just different categories, separate categories. So I would say that this is a nominal level of measurement variable. It's not ordinal. There's no ranking associated with this. So we go back now to our example. Just take me 1 second to go back to this. and we look back to our test of association with Chisquare. So the variables we are working with, which are both nominal, include gender and types of education. So a directional hypothesis might be that more women will have social work degrees than men. Okay, so there's a correlation, the test of association, and we're working with some of these different categories included in nominal levels of measurement. Okay, so you could do this with pretty much any variable that you would like. You just have to identify nominal levels of measurement variables and examine the relationship between them. If I wanted to give another example, we could look at race, and we could compare different race categories and the types of education that each racial group had completed. And that might be another example of two variables that we might use a chi-square test to analyze. Okay. I'd also mention that there are another category of statistical tests. These are known as group differences tests. And the first one includes the independent t-test. Now, with this particular test, as I mentioned, the independent variable is nominal level of measurement. So something like gender might be included as a variable that where we could use an independent t-test. And really what we're talking about are two groups. So gender wouldn't be the only example. You would come up with pretty much any nominal level of measurement variable that has two groups. And we're comparing the average scores between these two groups to see if there's a significant difference between the two groups. So when we talk about men and women and their self-esteem, is there a significant difference between men and women in their levels of self-esteem? That's essentially what we're talking about. Now, this is a parametric test because the dependent variable is interval or ratio. But if you wanted, you could use the Mann-Whitney U as a non-parametric alternative. Okay. Now, what I'd like for you to do is think back through the post-presentation survey data. So this survey that we've been looking through, I want you to identify two variables that can be used for this type of statistical test. And I want you to phrase an appropriate research hypothesis. So again, pause the video just for a moment and think through or try to identify an independent variable that's nominal, that has only two groups, as well as a dependent variable, which is interval or ratio. All right, you should have had time now to pause and think through two variables that might meet the requirements for the independent t-test. And an example that I give is the relationship between gender and presentation satisfaction. And my hypothesis that I would develop would be that men will have higher presentation satisfaction scores than women. Might not be true, but it's a hypothesis, and it's one directional. And it uses all of the appropriate variables for the independent t-test. All right, our final statistical test that we're going to be talking about today is the one-way ANOVA. The one-way ANOVA uses an independent variable that is nominal, but instead of just using two or more groups, we're talking about three or more groups. The dependent variable, like the independent t-test, is interval or ratio. This is also a parametric test, but there's a non-parametric alternative, which is the Mann-Whitney U. Now, this is a test of group difference. So we're talking about the different scores or the differences in the mean score of three or more groups which have been categorized using a nominal level variable. So an example of something like this might be, as I mentioned a little bit earlier, there will be a significant difference in the satisfaction scores between different racial groups. So race is nominal level of measurement, because we're talking about different categories, but there's no ranking associated with those categories. And we're talking about a dependent variable, which is satisfaction scores. So is there a difference between these different racial groups in terms of their satisfaction scores. And my hypothesis is that there will be a significant difference. Now, that particular hypothesis does not have a direction to it. So this would be considered a two-tailed research hypothesis. We could develop a one-tailed research hypothesis that might say Asian Americans will have higher levels of satisfaction than the other racial groups. But you want to make sure that your hypotheses are based upon some sort of theory. So this activity, try and develop a hypothesis that makes sense, that would actually be found, or that we might want to have confirmed in real life. So take a moment, think it through, see if you can come up with another set of variables that could be used, or that might use a one-way ANOVA. Okay, this brings us to the last portion of our class today, which is the homework assignment. So let me actually go, and I'm going to open up the homework assignment in this window. This has also been included on Blackboard, so it's all there, but it does require you to use SPSS for this particular assignment. Probably a little less intimidating than you think. So let's run through some of the research or some of the questions that are included on this homework assignment. You are going to need to make sure that you do the reading and that you review this video in order to be able to complete this homework properly. What I want you to do is use the data set that's been provided to you under Session 9 in Blackboard. The data set represents potential answers that people have given to the survey that we have been working through for our entire class today. So it's just responses to these different questions. And I'm going to want you to analyze some of the data available here. All right, so the first question is compute an overall satisfaction score. And I want you to paste a copy of the frequency distribution table into your answer to show that you have completed this step. And your table will look something like this. So it's a frequency distribution table of the overall satisfaction score. You have to be able to compute this score yourselves. So in order to do this, you're probably going to want to refer back to some of our previous PowerPoints and handouts that we've been using. And I want you to compute satisfaction score. And I want you to state a one-tailed research hypothesis as part of your second research or homework question. State a one-tailed research hypothesis predicting the relationship between age and overall satisfaction. And I want you to identify what are the independent and the dependent variables in question number 2. What are the levels of measurement? What type of graph would be most appropriate for the dependent variable in question 2? I want you to run this graph and paste it in your homework results. Again, you're going to want to refer back to the handouts that I've given you previously on how to go about running graphs. And then I want you to paste it to this homework. What statistical test appears to be most appropriate in examining the hypothesis that you stated in question number 2? So for this, again, you're going to want to make sure that you appropriately identify the independent and the dependent variables, what their levels of measurement are, and then you will go back to your statistics cheat sheet, and you will want to identify, based upon the level of measurement of the DV as opposed to the IV, what is the appropriate statistical test that should be used. And then what is the corresponding non-parametric alternative for the test that you're using? And if the appropriate test is a non-parametric alternative, then just state that there's no parametric alternative, or state what the parametric alternative might be. All right, then I'm going to want you to complete the same set of steps for one additional set of variables. I want you to compute a total practice score using questions about my own practice. So these are the variables that you want to add together. And I want you to paste the frequency distribution table below. So I can confirm that you've completed that step. And I want you to state a one-tailed research hypothesis that predicts the relationship between gender and the overall My Own Practice scores. Again, make sure you're referring back to the PowerPoints and some of the examples that I've given if you want a solid example of how to go about doing this step. Identify the independent and dependent variables as well as their levels of measurement for question number 8. Question number 9, run a graph for the independent variable. And I want you to paste the graph in these homework results. And then finally, question number 10, what is the test that would be most appropriate to examine the hypothesis that you stated in question number 1? What is the correct non-parametric alternative? And that is your homework for today's session. The homework can be worked on in class today. It does require SPSS. Again, SPSS is found on the main campus computer labs as well as in the computer lab in Carnegie. I'm not sure when Carnegie will be back open again. So you may need to go to the computer lab on the main campus to complete this homework. And finally, the homework will be due during our next class session, which I believe is on November the 10th. If you have any questions about this homework, please feel free to email me at any point with questions you may have. I really do appreciate you participating and watching the video session today. Good luck with the homework, and good luck with your families, and your housing situations, and everything following the storm that you've experienced. Thanks.